hold on. Like,
Absolutely.
Wait,
let's not go into that because
we're
the
like
atheists
way
of
off
the
topic.
1960s and 70s they debunked the moon mission. Madeline McMurphy or whatever, American Atheist Foundation, they proved that the Apollo program never happened. So that's you got people like George Carlin and stuff. So you don't need flat earthers for that. You can just have the atheists go debate the theists about the moon mission, and the atheists can tell the theists how they were wrong and whatnot. So it's
it was
not really
Madeline
a
Murray
flat earth
O'Hare.
topic.
Yeah, and I would like to get back to the original claim, which was about the water curving around the globe.
Yeah, which is photos from space.
No, not photos. Video streaming from satellites from the International Space Station.
Which is the same thing, a photo is just a lot of...
Are you saying that a video or a live stream is the same as a photo?
The International Space Station. Are you serious?
Yes.
So you don't know that like a video is composed of like 120 frames to 600. I mean, you could have a 30 frame per second.
Excuse me. So the International Space Station, you're talking that place where I go to on YouTube. It's a live feed. And when I start asking questions like, why don't I see any planes between the Earth and the ISS, or and then they block me. They won't let me ask any more questions because it's like they don't want to answer that shit. They don't want people asking those things. Oh, that ISS. Okay, I got you.
They really block you from doing that? That's hilarious. Holy shit. I mean,
You go and do that.
Surprised
That's why
me.
you don't see shipping like lights from ships going across the ocean, or airplanes taking off or landing from airports, or you go and do that, and you'll
when we
get the
see
same
a boat
result.
go over the horizon, it
You'll get
always
the
goes from
same
top to
result.
Where-
A
bottom as
boat
it goes
going
over the
over the
all the
horizon
horizon.
every
Okay,
time.
space
whoa,
junk?
your boat. Excuse me, your boat going over the horizon. Complete that circle. You're living on a pretty small fucking ball there, bud.
Still a ball, bud.
Okay, well, your claim's a hot mess. Do you got another one?
How is it a hot mess? If you're disagreeing with gravity, what's your alternative explanation then?
Of
Do
what's
you know
gravity? Yeah.
the 24-hour live stream isn't a 24-hour live stream? You do know that, right?
Yeah, every 90 minutes it stops for a half hour. Anyways, you're all forgetting. Elon put a Tesla in space. It's orbiting Earth right now. You're all forgetting that. Like, come on, get with the program.
What's your alternative explanation other than gravity then?
Well, let me ask you a question on that. Sir, what gravity are you referring to?
What do you mean?
Can you specify?
Gravity?
What gravity?
What
What gravity?
happened?
Let me tell you something, right? So in this conversation, there's often two categories, okay, in which the term gravity is used. Okay, one being the descriptor for the cause that we witness of higher dense things tending to go down, right, and less dense things tending to go up. Okay, so that's one overall category, and the second category is the term being used to describe the phenomena of things going up or down. Actual category that this fits in. Okay, but I'm just holding down on what you are using the term for.
I'm using it in the way that Einstein used it, which is the idea that massive objects cause the bending of space-time.
Thank you. Okay, so it's the causal mechanism. Okay, so now again, to be more specific, are you speaking about? I guess you're speaking about Einstein as opposed to Newton.
I'm talking about gravity in the way that Einstein described it. Gravity is a phenomenon. It's not. I don't know if it's causal.
Well, according to Einstein, bending warpy space-time, right, is the reason why things gravitate toward, right? Okay, so now, let's talk about that. So
it's the phenomenon itself.
Sir, that phenomena of bendy warpy space-time is the cause for things tending to gravitate towards things with higher mass.
No, I'm just describing the phenomenon itself. I'm not assigning a cause to it.
You're not.
No, sir. That's not how Einstein describes it. Einstein describes it as bending, warping space-time. The bending and warping of space-time is the reason for why things with mass tend to be attracted to other things with mass. The Earth is big; it bends space-time, and then things kind of quote unquote roll down or float down a funnel of bent space-time, so to speak.
Exactly. You don't get to sneak in things into the observation that you didn't observe.
No, we've observed.
Right. So the reason why
we've observed space-time being bent.
Hang on. So here,
Yes, we have.
this is what I'm trying to hone down on. Okay. So do you or does anybody have a scientific experiment, okay, where they've actually hypothesized bending and warping of space-time and then gone to show by varying the independent variable or the independent variable in their experiment that bendy warpy spacetime is indeed you would think, right, that since the early 1900s that there would have been at least one experiment done to validate the claim that bendy warpy spacetime is the cause for gravity before successive experiments or observations or whatever you want to call them were done based on these supposed theories, right? So between the 1920s and now, there should at least be one. Can you cite one or not?
No, off the top of my head, I can't cite one.
Okay, so therefore, what you're basing your claim on is what we would call a theory. The theory of general relativity. Would that be a little bit more accurate to say than the proof of gravity via general relativity or what have you?
That wouldn't be a theory. That would be an assertion, a baseless assertion.
So I got one for you. I Googled it. So the pound replica experiment was in 1959, and it measured the gravitational redshift of light.
Okay, so what did they do in this experiment? Let's walk through it.
Okay.
First, what did they observe? What were they trying to figure out, like, the reason for?
They were seeing if photons would gain energy when descending through a gravitational potential, and if they would lose energy when rising through a gravitational potential.
No, for this to be a scientific experiment, they observed something in nature and they went, "Oh, that's interesting. I wonder what's causing that to happen. Let's develop a hypothesis about what's making that happen." But that's where it starts.
Well, so
right.
in science, it's not just solely based on experiments.
So it wasn't an experiment.
What's important in science is predictions that are then verified later on. And Einstein predicted gravitational waves.
An experiment.
Hold on a second. Then. Einstein predicted gravitational waves, and 100 years later, they were observed at LIGO. Now I don't know
so
an experiment off the top of my head, but that should be good enough.
Oh my god, dude!
You're talking while I'm talking, so don't complain about being overtalked, dude. I just cited one, dude. You want the link?
Is it an experiment or not?
Yes, it is.
Yes, it is, T-Dub.
I'll put it in the fucking chat.
Okay, what was the dependent variable?
Here, you can look at it yourself. I'm not going to explain it to you.
No, sir.
It sounds like the dependent variable was
claim.
shifting
Okay,
a
I
photon.
got it.
Sir, this is your claim. This is your claim, okay? You are putting this on the table. We ought to walk through it together.
Here,
right? So you're making a claim that this is okay. So it's good for reference, but let's try and articulate this together, right? So what's a scientific experiment composed of, sir?
Well,
there's about 4 or 5 different constituent parts.
Why don't you tell me?
You talking about the scientific method? Because the experiment will be one step. The experiment will be one step.
The scientific method does not depend on experiments. Experiments can be part of it. It does not necessarily include experiments.
Experiments are one of the steps of the scientific method.
Yeah.
Thank you for clarifying. So yeah, so could you break that down for us, please? Okay. And then we'll try and pinpoint what actually applies to this thing or not.
So in a scientific experiment, you start with a hypothesis, and
No,
That's
first,
based
first
on
you
an
need a
observation of
natural
a
observable
phenomenon.
phenomenon. The first step is a naturally observable phenomena.
Yeah, you observe a
The
phenomenon.
first step, you need an observable phenomena. That will be the first step.
Okay.
Thank you, Gemsy. I got this.
Yeah, thank you for
I
correcting
got this. So let's walk. Yeah. So let's walk through it.
So you observe a phenomenon, and then you have a hypothesis based on that, and you do an experiment.
You need a
to
valid
test your
hypothesis. You need a valid hypothesis. It's gonna be like I observe water boil, and my hypothesis is that Superman is projecting his eyes laser from space, and that's causing the water to. That cannot be a hypothesis. The hypothesis has to be a valid one.
Right. So
thank you, Gemsy.
That's a valid hypothesis.
I got it.
Just means it's a statement that can be supported or disproven. That's an important thing, is that it can be proven or disproven.
Exactly. You need a valid hypothesis, not just any hypothesis. You need a valid one.
Right.
And then
Now,
so you're in an experiment, you're testing that valid hypothesis by manipulating different variables. You have
right.
So you have a factor being changed, and then you have a measured outcome, and you have a control group that doesn't change. And then you collect your data.
Thank you.
And see if it proved your hypothesis or disproved it.
Thank you very much. Okay. Now let's hone into the hypothesis section. Right. You already outlined it. Right. There are how many constituent parts of a hypothesis?
I'm not sure.
Let's say 3 general categories: independent, dependent, and control variables.
Okay. Yeah.
You use different terms, but that's applicable. Great. Thank you very much. Okay. Now, when it comes to gravity, right, and special relativity or general relativity, what was proposed by Einstein, what were the independent, dependent, and control variables in his quote-unquote experiment, which was not an experiment, but maybe you can cite an actual experiment that was based on that did have these components to actually further solidify his theory. Would you be able to provide that for us, please?
So are you guys asking about an experiment that just proved gravity? Because that would be a lot simpler for me to give an example of versus something like gravitational waves or lensing.
I didn't ask about gravitational waves. I'm talking about the theory of general relativity.
Okay.
Right? There's supposedly a hypothesis that bending warping space-time is causing gravity. Now, can you cite an experiment that confirms that?
I don't agree with that definition.
No. Okay. Well, what other definition is there, sir?
All I'm saying is that the bending of space.
What other definition is there, sir?
Is describing the phenomenon. I'm not saying that that's what causes it.
Sir, this is the claim on the table. Okay, the claim on the table is that bending and warping of space-time. Okay, these two general abstractions, one of which is composed of 3 parts. Coalesce together, we get a 4-dimensional quote unquote fabric called space-time that is bending as a result of higher or lower mass, right? Causing things to attract to each other. The whole point why I'm going down this road is basically trying to figure out what is this bending and what is this thing called space-time being bent and warped to begin with. What has been done to actually validate the quote-unquote existence of this ontological entity called space-time?
So I just want to say real quick that I think that I think what you were saying is correct, but if I can rephrase it, you can say that the warping is what causes the attraction, and the reason that it causes that, because I think that's what you're asking me, is that if you imagine what you described, the 4D surface, like a manifold of space-time or fabric, if you imagine massive objects as like I'm sure you guys have probably seen the video of like
demonstration. Rather than us imagine it, demonstrate it.
I'm sorry.
Show us a demonstration.
Do you guys not use your imaginations ever?
Sir,
is that a bad thing?
Yes.
You never imagine things in your mind.
Check this out.
All right.
Check this out.
Okay.
This is what is used when you're forming hypotheses, and that's all great and that's all well and good. but then it needs to be taken out into the real world and tested, right? You're imagining, you're conjuring up possibilities as to why something is happening, what things are correlated, and what is more dependent on the other, perhaps, if any, right? And then you figure it out by actual experimentation, testing things out, clunking things together, and forming it in a coherent manner to be communicated to other people. The imagination part is basically the second step, right? You see something, you observe a phenomena, and then you do that type of business. Okay, it's only a small part. Now, if you're asking that, if you're basically suggesting that that's all that's needed, right? That's where the fault. That's where the thing becomes faulty, because you need to take that theory out into the real world and ensure that it's actually valid, that there's actually a causal relationship between X and Y. So what we're asking for here is, what is the thing that was done to demonstrate the causal relationship between X and Y, i.e. X being the bending and warping of space-time causing the gravitational attraction, so to speak.
Something to fall.
Relativity.
Is it possible for me to share a video in here or no?
That's not what I'm asking for. That's not what I'm interested in.
Well, I was just.
I don't think anyone else is. You can do what you want, sir, but I don't know if it follows this conversation.
Well,
if you can articulate
I'm going to attempt
you can.
It, and if it doesn't work, then
yeah, send the video, and perhaps articulate something within it using your own words.
Yeah.
Right. Summarize something and make it cogent to your point. But I don't know if listening to 4 or 5 minutes, 10 minutes.
No, it's not gonna be that
video
long.
is worth it.
So
okay.
Well, you keep conflating Newtonian with Einsteinian by saying the word attraction or attracting. Attract. It's not attraction. It's not force. It's not a force.
Hold on. I just want to answer this question, which I was trying to answer. So I don't know if you guys are looking at. If you click on my little profile, it'll make the video bigger. But so this is a visualization of. It's not imagination. I know you guys are scared of that word, but this is what I was basically trying to describe.
That's not true.
It's a visualization of what you imagine to be happening.
Right.
Sir.
I don't see what's wrong with visualizing.
Sir, just so you know, my device is kind of glitching out, so I'm having trouble actually watching the thing. Oh, there you go. It's exactly that. Okay, so it's the fabric.
You guys have probably adding assertions.
Listen. This is a very poignant visualization for the idea. Okay, no one disputes that. It's actually it's quite appealing. I'll grant you that. Now, what is the demonstration out in reality that this is actually what's happening? I.e., that there is this ontological entity called space-time, which acts like a fabric, which can then be bent and warped, manipulated within an experiment, causing causing more of what we're describing here as gravity.
Causing anything at all, causing anything.
I mean, sir, like with this type of demonstration, anyone could replace the term bendy warpy space-time with fucking unicorns and leprechauns, and say, oh, look at all the imagined out, flattened out unicorns and leprechauns. Replace G with L and U or whatever in the equations, and it works. My model works. Therefore, there must be imaginary leprechauns and unicorns out there causing things to warp and bend together based off their mass. You follow that? Like
yeah,
there's no without the actual.
Exactly. It's kind of like if I have faith that magical unicorns exist, it's kind of like having faith that Jesus exists.
Hey,
hang on, sir.
Atheist, what's
the
atheist explanation?
Crit, I got
the atheist version of gravity.
Crit, I got this.
There's
sir,
no
do you see how
version of gravity?
Sir, do you see how you do? Sir, do you see how you just pivoted 90 degrees? Why did you bring up anything about faith and Jesus and shit?
Why did you
Who's
bring
talking
up
about
unicorns?
that? Because my point is, you have a variable or a set of variables which are undefined and unmalleable in this theory, There's no experiment that's actually demonstrating the manipulation of them causing the supposed cause that you're invoking. Okay, so therefore it's suitable. It's just as fair to replace any of those variables with any other variable, not have to manipulate those, and then make the claim that those extraneous variables like unicorns and leprechauns are the cause of this thing. And then you can create a story, some philosophical jigger about why they have a preference for this or that or the other thing. You see, the storyline comes after the modeling. Okay, the modeling itself, I don't think anyone in here would dispute, for example, the model of the inverted parabola, depicted by some of the experiments demonstrating Newton's theory, right? You throw a ball up in the air, it creates a parabolic arc, and then comes down, and then you measure it, and it's an on average a 9.81 meters per second squared acceleration, all that stuff. I don't think anyone in here would dispute that measure.
Paces when I brought up an example of manipulating time.
I would like to respond.
Mr. Peanut Gallery getting in here. Go ahead.
So, you asked what, in my opinion, is the cause of it. I cited a visualization.
I didn't ask your opinion, sir.
Okay, well, you were asking me about experiments.
I asked for experimentation, and I asked you to cite that experiment, sir. I didn't ask for your opinion.
I have one for you.
I didn't ask for a visualization. I asked for an experiment. Go ahead.
So, one example would be the perihelion orbit of the planet Mercury, the precession of Mercury's orbit.
Sir, here's the thing. You cannot use that. That is not an experiment. That is an observation. That is an observation. Sir, okay, let me ask you.
What's the first step of an experiment? Making an observation.
Observation.
Exactly.
Observation. Now, now check this out. What variables did an experimenter, a group of scientists or whatever, manipulate to see the cause or effect of this thing that you're observing?
The orbit of the other planets.
Okay, so what was manipulated, sir?
They can't manipulate that, but that doesn't.
Thank you very much. That's why it's not an experiment. That's why it's not an experiment. It's not a scientific experiment.
Okay, well, why don't I grant you that I don't have an example of an experiment? Why does that matter if we have direct observation of gravitational waves and gravitational lensing?
You don't.
Yes, we do. Yes, we fucking do, dude.
No, you don't. You know why?
LIGO.
Sir,
LIGO.
You have more.
LIGO.
I'll tell you why. You have more.
Dispute
sir,
LIGO.
You have more.
No. Dispute the gravitational waves observed at LIGO.
Unicorns.
No. Dispute that.
Dispute
the gravitational waves at LIGO, or I'm done. I'm fucking leaving.
Sir, okay.
No,
okay, leave.
Do your gish gallop. I'll wait. That's my example.
Then don't
respond
fucking
to that.
No, there you go.
Respond.
Sir, you have
that's a
more
direct observation.
Phenomena.
Respond to that.
Okay.
I'll wait.
There is no cause. There's no manipulated variable. Okay, directly tied to the supposed cause, or directly tied to the supposed phenomena, indicating any sort of real cause.
Are experiments the only way
that's
we
not
prove
even
things in science?
except
How do we prove things in science? How do we prove things in science?
Through manipulation of an independent variable.
How do we prove things in science? How do we determine that something is the most
Through
likely
manipulation of an independent variable to see if it causes the dependent variable.
Is that the only step? What are the steps of the scientific method?
Observe natural phenomena. Propose cause. Develop hypothesis. Test hypothesis through experiment.
Okay, are predictions a part of that? Are verified predictions a part of science?
Your prediction is: I observed A. I predict B causes it to happen. So we're going to set up a situation and controlled environment in which I manipulate B, my presumed cause, to see if A occurs. Yes.
No.
Yes.
A prediction
that is precisely.
a prediction is literally
precisely
just saying,
prediction.
I think this is going to happen.
Exactly.
That's a
yes.
prediction.
So
that is not a scientific prediction. That's not a scientific prediction.
Okay.
It's only part of it.
Give us
Look in the crystal ball prediction.
Sir, it's only part of it. Okay. Your prediction is part of your hypothesis as you just outlined. Okay. Now the problem is if you're setting up a hypothesis that is not actually really a hypothesis, because you're truncating out almost a third, if not 2/3 of the entire composition of the hypothesis, i.e. you're truncating out, you're taking out the independent and the dependent variable, and you're just making a prediction, okay? That's not a scientific that's no longer a scientific hypothesis. You have no means of actually controlling anything to see what causes one thing or another. You're basically just making a glorified guess, formulating it or wrapping it in a nice pretty bow, calling it science with all the all the relevant constituent parts taken out. Okay?
Exactly. You're not making a prediction about something you already observed occurring. Okay?
Yeah.
You've got to say,
not that you've observed
right,
it
you've got to
occurring.
say, it will happen if I do B.
No.
A won't happen if I do B. Right?
Otherwise,
so you can't just say, I observed X to happen. I predict X will happen again. Oh, look, it did.
That's not what
I'm being scientific.
That's not what I'm saying.
In that sense,
just let him respond, Mick. Hold on. I want to hear responses. More back and forth.
Okay.
Go ahead.
So I'm just going to read definition for scientific prediction from Google. It says a statement that describes what will happen in a scientific experiment or investigation based on scientific theories and previous observations. So you're wrong on that one.
Thank you.
I'm not even
You
saying I'm not even saying that you have to have a previous observation.
Junior, Atheist Junior. Do you know who Richard Feynman is?
Did they fucking know?
I want you guys to respond to that. Don't ask me another question. Einstein predicted.
Just did. How would they know what they're looking for?
First of all,
what do you mean? What do you mean? He's
First of all,
describing.
Junior, listen, Junior.
What's he describing? If you look through a telescope with, with such sorts of equipment and do this and that, then you should get this result. Did he say that?
T-Dub.
It's based on mathematics and
He
theory.
outlined the exact steps that LIGO took. Is that what they did? That they followed his hypothesis to the T?
No, I'm just waiting for you guys to dispute.
Were they expecting to
the
see
observations at LIGO? Just dispute it. Don't ask me a question.
Tito, can you hear elbow theory? Tito, can you hear elbow?
Don't ask me a question. I'm gonna.
Hey, okay, sorry. I'm obviously butting over to top of people. I can't hear Elbow. No, I'm going to drop out and come back in.
I'm making sure that you can hear him because he was trying to address you.
Sorry.
For a second,
Sorry, guys. Sorry.
Did you think Junior? Do you think that Einstein was a scientific theory?
Can you say that again?
Do you think Einstein's general relativity is a scientific theory?
Well, yes, but I want you guys to respond to what I said.
All right. Wait. With you saying, oh, yes, do you understand what it takes to become a scientific theory?
I would think so. This seems like a deflection, though.
I mentioned it earlier. Briefly.
And me too, so that's why I walked down that line.
You need repeated testing.
I want you guys. I want you guys
what?
To respond
Atheist?
LIGO.
No, Junior. Because
you're dodging.
It can't become a.
You're dodging.
It can't be. Listen. It cannot become a scientific theory without Einstein doing the actual experiments.
What are you talking about, dude?
What?
Yes.
Okay, stop talking.
A scientific theory is something that has been tested, experimented.
With the scientific method, repeatedly.
Right.
Repeatedly.
All Einstein had was just an average Joe's, any old bloke on the street idea, story. That's it.
Okay. So, I wanted you guys to respond to the observations at LIGO, and I'm not really hearing a debunk. I'm hearing a lot of deflection.
It sounds like you don't even know what happened at LIGO.
Okay, well, why don't you tell me then?
You tell us. You're bringing it up. You're the
No.
one
You
with the
say you
claim.
say I
Go ahead
don't.
and
Yeah,
tell us.
you said I
Explain
no.
it.
You said I
Explain us
don't understand it,
from
but you
step
enlighten
one
me.
is
No.
LIGO
I
a
want you to
scientific
do it. You're
conclusion?
saying I don't know what I'm talking about. You
Is,
tell
is
us.
LIGO a scientific theory conclusion? Is that what it is? We have a scientific theory from LIGO?
No. You tell me what LIGO is.
No. Oh, okay. We don't.
Sir, in a nutshell, LIGO, what it basically did, it was a glorified measuring device. Okay,
Glorified.
it beamed light down some fucking long tubes, and the light came back. Then they measured some disturbance or delay in time of the return of the light sent down those beams. Okay, and then they're making a claim, right? Because of this very subtle delay, which was like, or whatever it was, a fraction of a fraction of a fraction of a millisecond or something like that. They're making this glorified claim that, oh, it must have been this gravitational wave that came from billions and billions and billions of miles away or X light years away. Okay. That's what that basically is. There's a disturbance in the path of light, and it must be because of this other thing, because some guy predicted that would be the case supposedly,
Oh,
but yet
oh,
never yet
affirming
never
the
but
consequent.
yet never even verified in the first place the foundation of the theory to begin with, which is not even really a theory. Okay, because there was no initial experiment to suggest that the variables at play were even relevant, even malleable at all to begin with. Okay, it's a story laid on another story with fanciful equipment and billions of dollars from governments. Okay, which gives it
Well
some sort of
spent.
air of credibility to a lot of
Well
people.
spent. Money well spent.
Okay, this is what basically LIGO is,
For an
sir.
affirming the consequent.
Thank you.
Money well spent.
Present affirming the consequent formal logical fallacy to the world.
Money well spent.
If Einstein's right, then we will observe X. We observed X, therefore Einstein was right.
Yeah, makes sense to
Yeah,
me.
affirming the consequent. All right, sir.
Affirming the
Well,
consequent formal logical fallacy.
I predict we are going to observe this
Logical
thing. 100 years
fallacy.
later, we observe it. My prediction was proved true.
Can
That makes
you
sense
address
to
that
me.
it's a
That makes sense to me. I don't know about you guys.
address the fact that it's a logical
It
fallacy?
makes sense to you. It
Yeah,
would make sense
if
to you
somebody
because you
predicted
understand
that we'll
science.
observe something, and then 100 years later we observe that thing, I would say that prediction probably came true.
Let me tell you something, sir. Let me tell you something, sir. The reason why it's labeled as a logical. Let me.
Yeah, hold on.
Yeah. He's not
getting. We gotta get into his
Go ahead,
atheist version of gravity, because that's a contradiction to Einstein.
Atheist version of gravity.
You've got Lawrence Krauss, who rolled out dark matter and dark energy. Or you have
when did he do that?
Yeah, or you've got Hawkins, who talked about black holes and stuff. All these are direct contradictory to the theory.
Hawkins?
Yeah.
Do you mean Stephen Hawking? I'm sorry.
Yeah.
I'm sorry, go ahead.
So that's why it's good to say which leg are you going to stand in? Are you going to stand in the theism version of gravity or the atheism version?
I don't think there's an atheist version of gravity.
Yeah, that's called dark matter and dark energy.
No, dark matter has to do with the density, the densities that we see in other galaxies and around the universe. And dark energy is just sort of a placeholder name that's been given to whatever is causing the rate of the universe to expand.
Yeah, and in that model,
in other words,
there isn't gravity anymore.
In other words, our equations don't match.
Yeah, in that model,
in other words, our equations
gravity.
Yeah, in other words, our equations don't add up by a significant order of a significant error margin. Therefore, we're going to create placeholders, put them in, plug them in, okay, and assign them arbitrarily large values to try and sort of make it make sense, even though we have no substantial evidence to suggest that these things even exist in the first place, except for the fact that they make our equations balance out. Okay, that's basically what dark energy and dark matter are, sir. In case you didn't know.
I think there's they're starting to find evidence for dark matter. Although I'm not making that argument. I believe that that is
Thank you very much. You believe it. Now, thank you for being honest for once in
no,
this conversation.
I'm saying that
Now,
I don't understand dark matter enough well enough to talk about the evidence. That's all I'm saying.
Exactly, and guess what? Most people don't either. They think it's real, yet they don't. That they're placeholders to begin with because the equations don't work out without them. Okay, suggesting that the equations are wrong to begin with, and that they don't have any means by which to actually validate the existence of these things because these things are so supposedly so astronomically large and far away that there's no reasonable way to actually